weather. It's arguably the most important part of seamanship for sea kayakers. In particular, we're concerned with wind and the effect it has on the waves and on our ability to travel. So how do you get the knowledge of the weather? Well, most of us have some knowledge. We can also rely on the knowledge and experience of other people. We get this from VHF radio weather forecasts, from radio, television, internet these days, and we can develop a sense of what other people think is going to happen. However, the best and most reliable view you're going to have of the weather is where you are on the beach at the time. That's the only time you're 100% sure, because that you know what is happening. And you look out there, you see the weather, you see the wind, feel the wind, and you see the wave conditions. You then take your best guess at what's going to happen in the future. Nobody really knows what's going to happen in the future on weather. Even the most sophisticated people can't get it right. So we have to live with a level of uncertainty. How do you develop the skills, this knowledge, this ability to live with the uncertainty of weather? Well, most of us begin gradually. We go out, we start off on a small, safe beach where the conditions are calm, and you set off in conditions where you know you can get off the beach if you have to. You know that if the wind gets up, it's going to blow you back onto shore, not out to sea. If it's at all possible, you set off and paddle into the wind, not going with it, so that when you're tired, you don't have to fight your way back against it. And you basically work your way gently into learning about the weather as you learn about kayaking. Even when we're fair weather paddling, we still must take into consideration the weather. The fact that we've identified it as fair weather paddling means that we've at least considered the sky, the sea conditions. The more prudent among us will also have checked the newspaper to see what the weather's expected to do, or check the TV weather report, or better still, check the Coastguard weather forecast on your VHF radio.
Rain forecast issued by the Pacific Weather Center of Environment Canada, 0400 Pacific Daylight Time, Thursday, April 22.
You can't always rely on the weather to stay as calm as it is out here now. It can get very rough. Storm conditions such as these can occur remarkably quickly on this coastline. It's really important, therefore, to choose your location very carefully. You want to make sure that you can find a bay or a pull-out point or a sheltered cove somewhere along your route, so that if the conditions deteriorate, you can get ashore, get back to your car easily. When you're ready to go further afield, a good place to start is a marine weather forecast. Now, the marine weather forecast, which is transmitted on your VHF radio and on the Coastguard phone-in channel, is different from the weather forecast that you're going to get from your radio station. It focuses not on the sun and the rain, but on the wind conditions, on sea conditions, and on the visibility.
Winds west 10 to 15 knots, rising to 15 to 20 this afternoon. Sunny with cloudy periods today, clouding over tonight. Outlook, winds becoming moderate easterly, then shifting to strong westerly. West Coast Vancouver Island south section, winds light, rising to southeast 10 to 15 knots this morning, and to southeast 20 to 25 over the north section this afternoon. Winds varying to southerly 15 overnight. Increasing clouds today with rain developing overnight. Morning fog patches, combined seas near 2 meters. Outlook, winds varying.
A less detailed outlook for the next day will conclude the area forecast. Lighthouse, and to a lesser extent automatic buoy reports, give wind, visibility, wave height, and barometric trends for specific locations. These are usually updated every few hours.
Leonard Island overcast, visibility 15, sharp low southwest swell.
The same forecast is available over the phone or from a website that you may find by using a search engine and typing in marine weather forecast and your area. You can only do this for the first day of your trip, but it still provides useful information and a good format for your weather log. Even marine radio forecasts can be of limited use. You need to become your own weather station. Now, this means becoming familiar with observation and understanding what you're seeing. The clues are all around you. Sometimes they're as obvious as a great thunderstorm coming towards you, and other times they're more subtle. A ring around the sun, for instance, is an indication that moist air is rising and water vapor is condensing into ice crystals at high altitude. It takes time, patience, and regular observation of signs that affect our weather. But we can speed up the process by starting at home and systematically comparing our observations with the official forecast for our area. Wind is our biggest concern, particularly its strength and direction. This is going to affect our course, and it's going to affect how fast we travel. Perhaps more importantly, it's going to affect our decision as to whether or not we leave the beach. Now, a firm understanding of the basics of weather is what John Dawson teaches in his course. I'm going to hand over to him to take you through some of this.
It's calm right now, hardly a breath of wind to stir the surface. But the forces that generate wind are at work. Wind is essentially caused by the differential heating of the Earth's surface by our sun, the pressure differences generated, and the effect of the rotating Earth. The differences may be on a global scale, varying with the seasons, linked to the tilt of our orbit around the sun, or as local as a town relative to the surrounding sea or countryside. Towns readily absorb the sun's rays, heating buildings and roads and the air around them. The warm air rises and leaves a lower pressure space that surrounding air moves into. Adjacent cooler air sinks, creating a higher pressure as it pushes down on the air underneath. This effect causes a down pressure flow or wind. Wind is affected by the gradient, as well as the pressure difference between the high and the low. So if the high and the low pressure systems are closer, the wind will be stronger. Various units are used to measure atmospheric pressure, but most meteorologists use millibars and chart them by the use of isobars that join points of equal pressure. They look much like contours on a topographic map. The mean atmospheric pressure at sea level is 1013.7 millibars. This amounts to about 10 tons per square meter, or in gentler terms, 14 pounds per square inch. This large volume of cool air moving down a pressure gradient is known as an air mass. Its first impulse is to move directly to the center of the low, but the low is moving as well. So as soon as the air mass starts to move, the rotation of the Earth changes its apparent path, towards the right in the northern hemisphere and to the left in the south. But the low is still pulling it in, causing an anti-clockwise spiraling in the north and clockwise in the south, and whipping up its speed as it approaches the center of the low. This is the Coriolis effect, named after Gaspard Coriolis, the engineer who first described it. Wind velocity symbols show the speed and direction of wind. A half feather on the tail of a direction arrow represents 5 knots, and 10 knots for a full feather, all the way up to 45 knots. Storm conditions of 50 knots or more are indicated by a flag and additional feathers. Here's a neat trick for predicting wind speed. If the pressure drops, say, 4 millibars over a distance of 60 nautical miles, then winds of 10 times 4 or 40 knots may be expected.
When you've combined all the information you can glean from your VHF radio or your satellite images or your television or whatever, you still have to look out the tent in the morning at the weather and make your decision based on what's there that day. I've been on a trip where 8 days out of 10, the VHF weather radio report was 100% wrong for each of those 8 days out of the 10. Now, when you look out at that weather, you're going to need to interpret what you see, which involves having an understanding of the basics. Once again, John?
We experience weather in terms of the temperature, the wind speed, the precipitation, and the amount of cloud and sunshine within our ken. Some weather conditions are generated locally, but the larger synoptic systems are global in nature. The driving force is, of course, our life-giving sun, beaming down through the atmosphere at the rate of 800 trillion kilowatts, or a quadrillion horsepower. This is not evenly distributed. Some parts of the world get more than others. Clearly the tropics are the warmest, and the poles are the coolest. And this, combined with the remarkable properties of water and the rotation of the Earth, gives us our weather. A scientist named George Hadley theorized that the warm air would rise along the equator and move north and south in the upper atmosphere, cooling and sinking at the poles, forming what was called a Hadley cell of circulating air. He was partly right, but in practice it is a little more complicated. And a century later, William Ferrel described a system of 3 cells, whereby cold surface air moving from the poles caused impinging warm air moving from the temperate regions to rise over it, thus lowering the pressure and lifting to spread out in the upper atmosphere. At high altitudes, when southward moving air encounters Hadley air moving from the tropics, ridges of higher pressure ensue as the colliding air masses pile up and push downwards. All these air movements are modified by the rotation of the Earth and the Coriolis effect. In the higher latitudes, the most direct effect is in the formation of frontal lows, generated by warmer air rising over the cooler polar air. Frontal lows bring us much of our unpleasant weather as they spiral inwards and move eastwardly across the oceans.
A good way for you to develop a sense of the weather and to check up on the accuracy of your weather forecasters is to keep your own log. Now, Dan Lewis calls this pastcasting.
It's really hard to forecast weather, but one thing that's 100% accurate is pastcasting. And that's something I try to do when I'm out on trips. I pay careful attention to what's happening to the weather. I listen to my weather forecast in the morning and I write it down in my logbook. I just have the logbook sheets laid out before I go, fill in the weather forecast, and then throughout the day, I observe carefully what's happening to the weather and I make notes on what I observe. The interesting thing is by the end of the day, you can look back and see what happened and you can realize that they were actually quite accurate. Sometimes the timing's a little bit off, but usually the forecast is quite accurate. And this is a way to teach yourself by pastcasting, by practicing that. You can then start to see the patterns that emerge, the arrival of a warm front, the arrival of a cold front. What are the signs that indicate that happening? Next time that happens, you'll know what's coming. Here's a good example of what I'm talking about. A logbook I made last October. In the middle of October, the forecast called for a front crossing the outer coast in the morning. And then when you look down at the notes I made at the bottom, 11 o'clock the winds were peaking southeast, 11:30 the sky started to lighten, rain was easing, and by 12:45 the winds were light westerly. So it was a very clear progression there that I observed when that front that was forecast to cross the outer coast did indeed do it. It allows me to pinpoint the exact time it crossed the outer coast and to understand what that's going to look like in the future.
I used to fly by the seat of my pants, so to speak. But Dan's past casting showed me that being methodical can really help in the learning process. And I use this little device, which is a atmospheric data center, to help me make accurate recordings. It measures wind speed, temperature, barometric pressure, and a host of other things. And I first record the wind speed, and then the barometric pressure. And on the device itself, it has a little graph over the last 24 hours. And I make it simpler by just writing down that graph for the 24 hours, noting the high and low points. And then I have a constant record of the graph that it keeps. The temperature is quite a difficult thing to record, because it just records the temperature of itself and how the sun or the environment heats it. So we cannot just pick it out. It may have been in our pocket, it may be on the boat, and it will measure different temperatures. So that requires special care. Humidity the same, and I hang it in a tree at night and under the shade and measure the evening temperatures and the morning temperatures. And when paddling, I just have to feel what the temperature's like. The usefulness of the device is that it very accurately records barometric pressure. And barometric pressure is the real barometer of weather.
A barograph tells us not only the current and past pressures, but also the rate and direction of change. When pressure is increasing towards a high ridge, sinking air becomes further compressed, warming and drying in the process. Clouds disperse and the sun shines through clear skies. As the top of the ridge approaches, the change in pressure or the gradient eases, and so do the associated winds. Winds will pick up again and change direction as the ridge passes and the downward gradient increases. Pressure will remain high for a while, but because it is decreasing, the warming and drying effect is less, and this trend will continue as the trough approaches. Low-pressure systems are caused by rising air, which cools and moistens as the air rises. Clouds may form with rain and wind, especially along the associated fronts and if the gradient is steep. In the centre of the trough, winds may become variable and lighter, and though they will pick up again on the other side, they should not be as intense as on the approach side. At this stage, pressure, though still low, is increasing, and the air will become drier and warmer.
Some of the terms you're going to hear on your weather radio are really quite specific. For example, light winds refer to conditions where the winds are less than 12 knots. Small wavelets start to form at around 5 knots. And whitecaps start at around 10. when waves may be up to half a meter or between 1 and 2 feet. Moderate winds are in the range of 12 to 19 knots, when waves may grow up to 2 meters or 6 feet in open water with many whitecaps. Most paddlers will not set out in winds stronger than 19 knots. Strong winds are sustained wind speeds in the region of 20 to 33 knots. Waves of 2 to 3 meters or 6 to 9 feet may form in open water with foamy crests and spray. At this point, a small craft warning is issued. Good reason to stay on the beach unless you are following a protected shoreline. Mostly wind speed is given in knots, but check your units. If they can screw up $1 billion Mars mission by muddling their units, it can easily happen to you too. In addition to increasing your risk of capsize, wind also affects your speed and your control of your boat. Most of us don't go out in winds over 15 knots. However, once you know what you're doing, it can be a lot of fun to be in a strong wind with a following sea. It does help if you have a loaded kayak and if you're using a good rudder. This means you don't have to spend energy controlling off the waves, and you don't have to worry about your course so much, that you don't have to use your paddle for controlling your course. In addition, use a low paddle stroke. This means that your brace is readily available if you need it. It also means that you're less likely to catch the blade of the paddle in the wind and flip you over. Part of each weather report consists of data from different automated weather stations or lighthouses. This is the most accurate part of any forecast, since it's based on recent measurement and not subject to interpretation. Usually weather radio information refers to exposed positions, and you may start to wonder what they're talking about when day after day you see good weather and hear small craft warnings. It is probably going to blow at a more exposed location, so consider it a proceed with caution warning. This is part of developing a weather sense. Dan writes it down, others just build a mental picture. Whatever your style, you need to develop your weather awareness skills. In particular, pay attention to signs of changing conditions. These are the tools to start your own weather station and sharpen your powers of observation.
The most obvious sign of change is in the development of clouds. And clouds come in two basic forms: heap clouds, or cumulus, and layered clouds, or stratus. Normally we see only a small area of sky at any one time. But if we take a leap upwards and look at the big picture, we can see half the earth covered in cloud. Clouds appear to float, magically buoyed by the air around them. But ice and water are heavy and are falling all the time, kept aloft only by the rising air that helped to form them. The flat base of most clouds is where the water vapour in the rising air reaches its condensation point, forming the tiny droplets that make up the cloud. Some droplets fall faster than the rising air and drop below the cloud base, where they evaporate back into vapour. Condensation occurs most easily around a nucleus, such as a microscopic particle of dust, salt, or an electrically charged ion. The droplets in their trillions that we see as clouds are very small. But when conditions cause them to coalesce, they may become large enough to fall as rain, bringing their bits of dust and clearing the air as they fall. Sometimes raindrops will evaporate before they reach the ground, forming a veil of virga under the cloud.
The turbulent updrafts in towering cumulus cloud may lift even large raindrops until they freeze and fall as hail. Let's see what some of the more common clouds look like. Cirrus clouds are the highest of all. They are made up of ice crystals and usually have feathery edges. They often look curved and wind-whipped in the form of mare's tails, but may also appear in the two basic cloud forms. Cumulus clouds develop where there are significant updrafts, and where the air is more stable, clouds are more likely to form as stratus or layered. The form and the height is the most common way of describing clouds. Alto meaning high. There is no sharp dividing line in cloud forms, and many are a mixture of stratus and cumulus. Nimbus means rain. Approaching weather systems can often be recognized by the displays they make in the sky. An approaching warm front is a good starting point. A frontal low formed by the meeting of polar and temperate air masses will often comprise of a warm front followed by a cold front. The warm front is indicated on weather maps by a red line with intermittent semicircles along its length. As the advancing warm air is lighter and more buoyant than cooler air, it floats above the slower-moving cooler air in a wedge-like progression. As the air rises and cools, the water vapour it contains starts to condense. First indications are a hazing of the clear sky, which may be seen as a ring around the sun or at night around the moon. Lingering or growing aircraft vapour trails are also indicators of increasing moisture high in the atmosphere. Warm fronts usually give plenty of warning. They are preceded by a progression of cloud formations, starting with high cirrus and descending through various layers of stratified clouds to nimbostratus, meaning rainy layered cloud. The rising air, augmented by heat released by condensation, often causes a steeper pressure gradient and stronger winds as the front approaches. The wet and windy weather may last for a day or more, but after the passage of the front, there is often a sector of warm and relatively stable air between warm and cold fronts, where winds will be lighter, even if the barometric pressure stays the same. Such conditions will often provide a window of good paddling. If a cold front is following, the window will not last for long. Look for a blue line with icicles along the front of it on the weather chart. Cold fronts occur when a mass of cold air pushes under warm air. The vertical movement is much more dynamic than the gentle rise of a warm front, and a bank of cumulus clouds accompanied by squally winds and heavy rain are likely to form along the line of the front. Thunder towers with hail and lightning are common in the more violent fronts. It's harder to recognize an approaching cold front. Its gusty winds and heavy rain can be on you without much warning. Some particularly nasty cold fronts are not associated with cyclonic low-pressure systems. The infamous norther, for example, is a dense cold air mass that pushes down the east coast of Canada and the United States into the Caribbean during the winter months. Veering to the right and following the coastline, it can be on you with little warning. John's team had an epic encounter with a norther during one of his expeditions.
Yeah, we sure did. We were paddling from Haiti up to Great Inagua, and we were out of sight of land just near dark, and this great grey wall came towards us. Just all of the northern sky went dark blue, and a low cloud, like a string of sausages, started rolling towards us. We couldn't figure it out. And the next minute, a waterspout formed. It went huge waterspout, probably 3,000 feet high, and it came within about 200 or 300 yards of us, and passed behind us. And then the wind just hit us smack. And probably during the next 4 or 5 hours, the wind went through 360 degrees, and we were battling it just constantly. There was flying spray. We could hardly breathe into this wind. And then it settled down to a steady 20-knot headwind. So, yep, we met the northers. An often neglected aspect of cold fronts and low pressure systems is the effect that cold rain can have on a group of kayakers. The chilling effect can quickly become a safety issue. It helps to dress and eat properly. In your kayak with your spray skirt fitted, you're pretty well insulated, provided your upper body remains dry. The dry suit, of course, is the ideal, but a fair alternative is a paddling jacket with the appropriate wicking layers underneath. Keep a spare pullover handy in the boat in case you cool off. Ashore when it's wet, I use a stove to quickly start a brew while the fly is being rigged and firewood is collected.
Trial Island, part cloudy, visibility 15, wind southwest 8, seas 1 foot chop. Carano Point overcast, visibility 15, winds calm, seas 1 foot chop, low to moderate southwesterly swell. Pacino Point, cloudy, visibility 15.
Marine forecasters are very concerned about range of visibility. They include it in their reports from lighthouses and buoys. This includes rain, snow, haze, and fog. Most ships have radar, and they can see through the fog. On the other hand, we cannot be sure that they are going to be able to see a kayaker on the water. John Dawson carries a radar reflector on his kayak, and he can tell you how you can paddle more safely in limited visibility conditions.
It's a clear day today. I can see right across the Straits of Georgia, 30 miles or more. But if I'm planning to set off on a trip where there is any possibility of fog, I like to be seen as well. So I take this little device with me. The honeycomb structure inside is arranged so that it will reflect a signal straight back to the transmitting antenna, even if the kayak is tossing around. I fastened it onto the back hatch of the kayak such that it can be detached from the kayak, and so that I don't have to drill holes in the body of the kayak. This means I can transfer it from one kayak to another without any modification.
The circular or diamond-shaped reflectors work in the same way. Some models are designed to fold up and slip in a compact bag when not in use. This type will return a signal from whatever angle it is received. This is a critical consideration for those who may be tempted to rely on makeshift reflectors made from tin foil or other handy reflective material. A 6,000-ton ferry may look beautifully serene as it melts into a bank of fog against a backdrop of massive mountains. But if you are down there, sharing its space, and not knowing quite where it is headed, then you'll probably wish that you were somewhere else. Commercial vessels have radar equipment and are usually responsibly managed. And though there is no guarantee that they will see you, the greater risk of collision comes from private powerboats, familiar with the location and navigating blindly on global positioning systems, or GPS. If there is any probability of fog, it is better to plan your route so that you can quickly reach places where bigger boats do not go, such as shallow water close to shore, or to the other side of lateral buoys and beacons that mark the navigable channels. The range of visibility is usually reported in nautical miles, between 0 and 15, which you may hear as 1-5 on the weather radio. Beyond that, most boats are below a kayaker's horizon. Fog at sea develops in two basic ways. Radiation fog forms on land during cloudless, calm nights, when the ground, radiating its daytime heat into the clear sky, cools the low-lying air to its condensation point and increases its density such that it moves out to sea as a land breeze or katabatic flow. It can be dense and persistent, but more usually it will burn off in the morning sun. Sea fog, or advection fog, is a different animal. It can roll inland in dense clouds and last for days. It is usually formed by warmer, moist air passing over cooler currents or upwelling cold water. As the low-lying air cools, it reaches its dew point and forms what is in effect a cloud laying on the surface of the sea. On Canada's west coast, it is often seen as an offshore bank extending across the horizon, and should always give a moment of pause before committing to an ocean passage. For with little warning, depending on humidity and the airflow, the bank may advance to inundate coastal communities and inlets. Sea fog can be generated continuously, day and night, and may completely overwhelm the sun's power to burn it off. Marine forecasters are often able to anticipate its movements, but they cannot be certain of its onset from one locality to the next. So if there is any possibility of sea fog, you should consider that uncertainty in your route planning strategy. Sea fog has a cold, clammy, foreboding presence, and combined with ocean swells close to a rocky shore, can be an unsettling experience even for the most hardened sea kayaker. There are always some who relish the challenge. On the Pacific side of North America, sea fog usually occurs in the warmest months, when the sea temperature differences are greater. But where warm ocean currents meet cold polar flows, it can occur year-round.
Thunderstorms are full of surprises for kayakers. The first one is going to be the squall line, which is the wall of wind that just drives down in front of the storm. It will pummel into a kayaker, and really the best thing you can do is to lie low, brace over into the wind, and hang on there until the wind eases up a little bit. Usually it doesn't last that long, maybe a minute, 2 minutes, maybe 5 minutes, but it will ease up and you can resume your paddling. And then of course there's the small matter of lightning. Take it away, John.
Lightning takes its annual toll of folk caught out in the open. So if the forecast or your own weather sense indicate a chance of thunderstorms, it is better to avoid crossings and paddle close to an accessible shore. Get off the water at the first indication of encroaching lightning. Stay away from open areas
sea caves, and from under cliffs, rock crevices, and particularly lone trees. Towns, houses, and restaurants provide good protection, as does a forest canopy. Try to keep dry. Insulate yourself from the ground using Ensilite or your paddle float. Oh, Fern and Erin are pretty chummy, but it is safer for everyone to shelter separately.
It's not only thunderstorms and fog that are generated locally. Much of the weather we experience is caused by local modification or even completely generated by the topography and the ocean around us.
Land heats up readily on a sunny day. The warmed air rises and draws moist, cool air in from the sea. This upward and inward movement is known as a sea breeze or anabatic airflow. During clear nights, the heat is lost more rapidly from the land than from the sea, cooling and increasing the density of the air, which then flows from the land to the sea. On an open coast, this katabatic flow is usually no more than a gentle breeze. Inlets will channel the airflow and increase its speed, especially at the mouth of the inlet where all the air must pass. At night, the cooling air will gradually start to flow down valleys and watercourses and accelerate to form an early morning outflow breeze. In mountainous areas, higher, cooler air may be held back by lower air until it bursts through as a sudden strong wind. Sudden outflow winds, whatever their cause, can be a serious hazard to kayakers, so it is important to recognize susceptible areas and seek out informed local knowledge.
During winter in Southern California and Baja, high pressures in the interior USA result in strong outflow winds that drive most Baja kayakers from the water by noon. These winds are known as the Santa Anas.
Canny kayakers will consider these diurnal effects as well as the area weather forecast when planning a trip. Afternoon wind may whisk you up an inlet at twice your normal speed, for instance, and unless there is a powerful synoptic system at work, the calmest times are evening and morning. If you make the effort to be on the water early, you will rarely regret it.
Things are looking up. Canny kayakers can use many of these effects in their route planning strategy.
A parcel of warmed air rising above an island will reduce the pressure beneath it and cool as it ascends. If it reaches its condensation level, a cloud will form right over the island, or a plume of cloud if a higher wind moves it to the side. A cloud on the horizon may mark the position of an island that would otherwise be out of sight. On his Caribbean trip, John Dowd used this effect as an aid to navigation. A developed convection breeze will tend to rotate in the same way as a large low-pressure system, so you may take that into account when circumnavigating the island. The main wind flow can also be affected by interaction with land features. Corner winds are caused by a funneling effect around headlands. On the downwind or lee side of the promontory, an eddy may develop moving in the opposite direction. The strongest wind may be right on the point or some way offshore. Gap winds form when the funneling effect is from both sides. In this case, the stronger winds will be close to the centre of the gap. In the north, when facing the wind, low pressure will be to your right. Along the shore, wind over the land will be slowed and diverge towards the low, reducing the overall strength. So if you have the option, keep the land to your right when facing the wind. If the low is to seaward, then land friction will cause convergence and increase the overall strength. So keeping the land to your right going downwind will give you the more powerful push. Winds blowing from land to sea or offshore winds can be deceptive, and many people have been caught out by the apparent calmness close to shore. The increasing strength away from the shelter or lee of the land may make it difficult or impossible to return against it. So beware of offshore winds. Mariners throughout history have lived in dread of lee shores. This is when the shore is to the lee side of the boat and the boat is being pushed towards it. A gentle lee shore is not much of an issue for a kayak. But a formidable shore like this one is a different matter. In moderate winds, lee shores are manageable unless something goes wrong. We were filming close to a rocky shore when the camera boat hit Jerry and flipped him. He was wearing his dry suit and Tina was ready at hand, but helping somebody back into a kayak in rough conditions requires practice and a cool head. But it is better to practice in a place where there is no risk of being driven onto surf-pounded rocks. If you intend to expose yourself to the hazards of wild places in rough weather, it really pays to be prepared. There is an element of risk in any sea kayak trip, so filing a plan with a reliable person before you leave is a good insurance policy. In Canada, the Coastguard more than encouraged the idea.
Tell me, Frank, what weather and safety services does the Canadian Coast Guard offer to sea kayakers?
Well, certainly we offer live weather broadcasts. We offer a continuous marine broadcast, a service that puts weather information, gale warnings, storm warnings, and notice to shipping information. But one service that's unique for the Canadian Coast Guard is a sail plan processing service. And with this service, we take departure and arrival information, description of vessels, a number of people that might be departing in a kayak or a number of kayaks, and take reports from them en route and make sure that they arrive safely.
One of the things I'm amazed when I look around this room is that you guys really seem set up to respond to kayakers. So you're really happy if we do this, if we call you up and give you this information?
Absolutely. We encourage first to file with a responsible person if you can do that on your own. But in remote areas or where filing with someone else just isn't possible, we definitely do strongly encourage file with the nearest Marine Communication and Traffic Service Center.
What are the obligations and responsibilities from a kayaker's point of view when we file a plan with you guys?
The most important thing if a kayaker does file a sail plan is that they make all required reports and that they close the sail plan at the required time. Because if we go 30 minutes without report, 30 minutes without a report, we're going to task search and rescue resources. So we have a direct line to a rescue coordination center, and somebody being overdue will result in a search and rescue response.
Okay, so we need to be really clear what the responsibilities for the kayaker are then. Mostly it's checking in if they say they're going to check in, and when they get into back home or into port, they call you up and say we're home safe.
Absolutely.
And that's what we want to see. Thank you very much.
Thank you.
Maintaining a trip plan requires reliable communications and a good backup.
Our trusty little weather radio has chosen this particular time for its battery to die on us after 2 years of use. We have an option here. We can harness the power of the sun up there and use this charger either to recharge the battery or to run the radio. I'd select a suitable slope of rock that will enable the unit to use its maximum ability here. There we've got it.
Red sky at night, sailors delight. Red sky in the morning, sailors take warning. Is there any truth to the old adage? In mid-latitudes, most of our weather systems come from the west, and if higher pressure and clear conditions are on the way, then light from the setting sun can pass through the atmosphere unimpeded, save for the scattering of most of the blue light, leaving the red to beam under any lingering clouds. If good weather is about to change, then the morning rays can pass through the clear air and briefly redden the encroaching clouds from underneath. It will not be long before they move in above and grey out the light.
An understanding of marine weather is fundamental to safe sea kayaking. Together with boat handling skills, navigation, and oceanography, it is a key part of the jigsaw puzzle we know of as seamanship for kayakers. But remember, although they have their place, watching videos and reading books is no substitute for experience.